We already saw the CPP reference page on the requires expression and saw that there are 4 types of requirements, namely simple requirements, type requirements, compound requirements, and nested requirements. To solve our problem with the overload resolution for different types, that is pointer type or the numeric type, from the last lecture, we want that the type traits expression are evaluated to true during type checking, and therefore we have to take a closer look at the difference between simple requires expression and nested requires expression. A simple requirement is an arbitrary expression statement, and it does not start with the keyword requires. I'll explain this shortly. It asserts that the expression is valid, which we understood in the last lecture through code demonstration with the std is arithmetic underscore v and std is same underscore v with different template parameters. And here in the requirements from the last lecture, the body of the expression does not have required keyword. If we add a new requirement in numeric type, namely param plus 1, the compiler will simply check if 1 could be added to the parameter param. And it doesn't care about the result, true or false, of the evaluation of each of the expression. And the compiler will only check if the language is correctly used on a given template parameter. And in the case of nested requirement, it is a requirement within the requires expression, and that's why the name nested requires expression. For example, in the modified concept for numeric type, each of the type traits within the body of the requires expression has a requires keyword preceding it. It implies that the expression is valid and must evaluate to true. We can also specify our own nested requires expression, which we will see in the later lectures. And now let me modify our concept to use the nested requires expression instead of simple requires expression. Let me switch to the editor once more. And here, if I simply add requires keyword, in the numeric type and also in the pointer type, and uncomment this code, I can also comment this code because I don't need this anymore. If I compile the code and run it once more, and voila, everything works. The call to the add one with pointer to int resolves to the overload with the constraint pointer type, and in the case of normal numeric type, it resolves to the overload with the constraint numeric type. And now I can modify one of the overloads of add1 to have more constraint than the other one. Let's say I modify the second overload and specify another constraint that the type t should not be of numeric type. Not numeric type t. I need to enclose this within a bracket. Let me be sure. Let me compile the code. Yeah, I need to enclose this within the bracket. The compiler says it should be in bracket. This looks a bit ugly, but that's what the compiler wants. But if you don't like this, then you can also put a bracket around the entire requires expression or the requires clause. Both works fine. Similarly, I can add another requirement on the first overload, namely the type t should not be of pointer type. It can be similarly done like this. And if I compile the code once more, yeah, this also works. I don't like the bracket like this, so I'll just change it and do it like this. It's a matter of personal preference. Alright, that's all I wanted to show you in this lecture. So enjoy learning modern C++ and stay tuned for more concepts in the next lectures.
Hello there.
If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website mastering-modern-cpp-features.thinkific.com. Thank you.